Hey there, Econ 365, Chapter 6, Part 5. This is going to be the most important video of all on torts, because what we're going to be doing is we're going to be developing the basic model that becomes the guidepost, that becomes the way, the reference point to how we think about dealing in an efficient manner with torts, precaution, damages, and sort of wrapping everything together. You may recall in the last, you better recall, in the last video, we showed the model with precaution on the horizontal axis, and at X with the squiggle, X with the tilde sign, that would be the legal standard, which we hope would be the same as X star, which would be the efficient standard for precaution. So any level of precaution below that X tilde would be in the forbidden zone, and you would be at fault, negligence. Anything at or greater than X with our tilde sign would be you'd be exonerated. You wouldn't be found negligent. Okay, so the reality is the cost of harm has to fall somewhere. So we need to kind of figure that out, and that's what our purpose is here. And the thing is, negotiation, unlike in what we've been talking about for weeks on end, is not feasible here. So how do we get the wrongdoer to internalize the costs when we don't even know whether we're going to be the wrongdoer or we're going to be the victim? So that's the motivating factor here. So what we're going to be doing is we're going to be developing a model on the social cost of accidents. And social is a term we don't use a whole lot. We normally think like external, like social cost would be like an externality, a third-party effect, and the like. But here we're really looking at the cost to society, which is going to be some combination of the costs associated with taking precaution and the savings associated with taking precaution, because precaution reduces the likelihood of an accident occurring and also reduces the likelihood of damages occurring. It could be some combination of the two. So let's go ahead. I'm going to throw several diagrams at you that's going to show how we think about all this. Okay, so you've got to position this kind of carefully, and I don't want to give too much of it away just yet. So let's kind of look there. So the top diagram is the one that we were dealing with in part 4. And now I want to look at the middle diagram here. Once again, we've got precaution on the horizontal axis. We denote that by the letter X. We've got dollar signs because we're measuring economic value on the vertical axis. And so we've got the cost associated with precaution, which is going to be W times X. W is going to be some sort of per unit cost of precaution. It could be the hourly value, for example, for someone who is a more careful driver, and therefore it takes them longer to get from point A to point B. You can see that the cost of precaution is upward sloping because W is assumed to be a fixed, for our purposes here, per unit cost. And so we have constant slope, but it is increasing. It's not flat. It's increasing. The more precaution, the more cost that we incur associated with that. Okay. That is the cost that we need to look at. And now we have to compare it with the benefit associated with taking precaution. That's going to be a little more complicated, because what happens is, as you take more precaution, now we're dealing with probabilities, because there's no guarantee. But the probability, the likelihood of an accident is going to go down as the level of precaution increases. And the savings on that would be that probability of an accident occurring times some measure of the damages associated with an accident. So we could talk about those damages being kind of like the average damages involved with an accident. Or if you are driving in an area that's a very expensive area, the average damages for an accident might be greater. If someone's earnings are affected, a wealthier area, people are earning more, driving fancier cars, so there could be more body damage and things of that nature. Those are complications that we really don't have to worry about, so we can think in terms of some sort of damage number. Okay, that's going to be the diagram on the bottom here. And so the diagram on the bottom here is going to have, again, precaution on the horizontal axis, dollars measured on the vertical axis, and now we've got a line that is definitely not of constant slope. And you can see that it gets flatter, it asymptotically approaches the horizontal axis, but it's never going to get there because you can't guarantee, no matter how much precaution you take, that you're not going to get into any sort of accident. So A is a constant, but P of X is a declining function of the amount of precaution that you take. So the bigger X is, the smaller P of X is going to be, okay? And this is obviously, we're looking at the cost side here, so you can see we've got the downward slope, but it's not a constant slope by any means because you can't guarantee no accidents occurring, but maybe even a little bit of precaution will pay off in terms of a quite large benefit associated with the likelihood of an accident occurring. Okay, so to come up with the killer, to come up with the model that is the focus of this chapter, we need to combine the two, because the expected social cost is going to be the combination of precaution and damages, okay? So that's the diagram that we have here. So I've taken the first two diagrams and now just grafted one on top of the other. So we've got our precaution line here. We've got the probability of an accident, our kind of benefit analysis is represented by this curve. The cost incurred is represented by this curve. And then when we add the two together vertically, we come up with the expected social cost. That's what SC denotes, which is the cost of per unit of precaution times the amount of precaution plus the probability of an accident, which is related to the amount of precaution we take times damages from an accident. And when we combine the two together, you can see we've got this curve that at its minimum point is going to give us X star, which is going to be the efficient level of precaution, because that's going to be the lowest combined cost associated with damages and the cost of avoiding an accident and avoiding those damages. Now, don't fall into the trap of thinking, oh, the minimum's got to be where the two lines cross. The minimum, and particularly relevant to those of you who have studied calculus, is actually going to be where the slope in absolute value of these two curves are the same, okay? And in my example here, so the slope of the absolute value, W is the slope related to precaution. P prime of X times A is going to be the slope of the diagram here. We set these equal to each other, and that's how we get the optimal precaution rule. It's going to be where W, which is the slope here, is equal to minus P of X times A, because remember, P of X, as X gets bigger, P is negative, as you can see. This is downward sloping, this is upward sloping. So when we set those two equal, then we have identified the most efficient place to be, and W is really the marginal cost associated with precaution. P prime of X, which is just the marginal change in the probability of an accident occurring as we undertake more precaution, times A, is going to be the marginal benefit associated with taking precaution. Let me focus on this again in case any of you are having trouble understanding this. The benefit you get is the safer you are, the lower the chance you get into an accident. So the savings are the value of the accidents that you can avoid by taking precaution, okay? Set those equal, that gives us X star. Our hope would be that X star and X tilde would be one and the same, and that would be kind of the way economics would try to have an impact on the law here with respect to torts, because you want the standard to be set at some efficient level that encourages the right amount of precaution, but not too much precaution. And I want to leave you on this video by asking a simple question. Can you be too careful? You bet you can be too careful. Anywhere to the right of X star, you're too careful, because the marginal cost exceeds the marginal benefit. You've done too much. Do you see that in the real world? You bet. Defensive medicine, where doctors order a lot of what might be redundant tests to reduce the chance that they get sued for malpractice. The cost of all those additional tests will reduce the chance of a misdiagnosis, but only marginally. And so the costs don't really justify the benefits. And so anywhere to the right here, you're being too cautious. Anywhere here, you're being too reckless. Okay, we'll continue in part 6.